This is chapter 18, problem number 11. The problem reads, two very small spheres are initially neutral and separated by a distance of 0.5 meters. Suppose that 3.0 times 10 to the 13 electrons are removed from one sphere and placed on the other. A. What is the magnitude of the electrostatic force that acts on each sphere? B. What is the force attractive or repulsive, and why? Right, so first thing you need to know is the charge of a proton or electron, which is 1.60 times 10 to the negative 19 coulombs, depending on whether it's a proton positive or electron negative. Here I have my two neutral charges, and the problem states that 3.0 times 10 to the 13 electrons were transferred from one of the neutral charges to the other. So to figure out the charge that would be left on each, we simply take the number of electrons and multiply it by the charge per electron, which is 1.60 times 10 to the negative 19. And for each of them, we get a charge of, well, for the particle that receives the electrons, it has a charge of negative 4.8 microcoulombs, and for the charge that donates the electrons, it has a charge of positive 4.8 microcoulombs. From here, we use the force equation here, which states that K equals Q1 times Q2, absolute value of Q1 times Q2 over the distance squared. And because the magnitudes of the two spheres are the same, we can consolidate that to just be Q squared, as you see here. And the rest of it is simply a plug and chug. The problem tells us our distance, our R value, which is the distance between them, and it also gives us K, which is a constant, which we know to be 8.99 times 10 to the 9. But you plug in these values and you get a final force of 0.83 newtons.